Section 4 contains useful facts for you to use when you want to find normal probabilities using the CDF function in your GC. Now, in this section, I will use X follows a normal distribution with mean mu and variance sigma square, and A and B are just two real arbitrary constants. Now, the first fact says this: if I want to write down the probability of X equals to any arbitrary constant, okay, then that probability is always equals to 0. Now, this is because probability is measured by area under the curve. And if I were to draw a bell and I look for A, then the area under the graph, okay, for X equals to A is just 0, because this line, X equals to 0, has no thickness. Okay? Now, this has got significant meaning because if I want to find probability X bigger than or equals to A, now this is the same as probability X bigger than A. The equal sign here has got no value added to probability X bigger than A. Okay, you can see this, right? If I have probability less than or equals to B, this is the same as probability less than B. And likewise for this and this. Now, note that this is very different in a discrete case. When it's a binomial distribution or when it's Poisson distribution, the equal sign most likely will have a bearing on the probabilities. Then for 2 and 3, facts 2 and 3, now these are things that we have seen before. Because we want to use the CDF function in your GC, instead of, or rather before I can key in bigger than A, I have to change it to a less than sign so that I can use the CDF function. Okay, so same thing here. I have a X less than A, bigger than A, sorry, and less than B. I have to rewrite it as X less than B first, then minus the probability X less than A. Okay. Then for properties 4 and 5, now these are rules rather, okay, that make use of the fact that the normal curve is symmetric about the mean mu. Okay, so in particular, when your mu is 0, then your probability X less than or equals to minus A is the same as probability X bigger than A. Okay, so this is probability X less than or equals to minus A. This is probability X bigger than A. Okay, and that is when your mu is 0. And because the line X equals to mu divides the curve into two equal pieces on the left and right, then the area on the left of mu must be the same as the area on the right of mu. Okay, so that probability is just half. Okay.